Earthquakes are among the most devastating natural disasters on Earth. They strike without warning, destroy cities in seconds, and leave scientists facing the same uncomfortable question every time. Could this have been predicted? With modern satellites, artificial intelligence, and global sensor networks, it seems reasonable to assume that earthquakes should be predictable by now. After all, we can forecast hurricanes days in advance and track storms across entire oceans. So why not earthquakes? The short answer is this. No, earthquakes cannot be reliably predicted with today's technology. But the long answer is far more interesting and far more nuanced. An earthquake occurs when stress builds up along geological faults where tectonic plates meet. These plates are constantly moving, but very slowly, just a few centimeters per year. Over time, stress accumulates until the rock suddenly slips, releasing energy as seismic waves. The challenge is not understanding why earthquakes happen. Scientists understand the physics well. The challenge is knowing exactly when and where that stress will be released. Unlike weather systems, faults are buried deep underground. We cannot see them directly. We cannot measure stress at every point, and the processes involved are highly nonlinear. Tiny differences in pressure, rock composition, or fluid presence can dramatically change when a fault fails. For decades, scientists searched for reliable warning signs, changes in groundwater levels, strange animal behavior, electromagnetic signals, or gas emissions. While some correlations have been observed, none have proven consistent or reliable enough to be used as predictions. This is why seismologists make an important distinction between prediction and forecasting. Prediction means specifying the exact time, location, and magnitude of an earthquake in advance. That remains impossible today. Forecasting, however, is probabilistic. Scientists can estimate the likelihood of earthquakes occurring in a region over years or decades. For example, they can say there is a 60% chance of a major earthquake along a fault within the next 30 years. This information is valuable for building codes and urban planning, but it does not tell people when to evacuate. Modern technology has significantly improved earthquake detection, but detection is not prediction. Seismic networks around the world can detect earthquakes almost instantly. Some countries operate early warning systems that provide seconds to tens of seconds of warning after an earthquake has already begun. These systems work because seismic waves travel at different speeds. Sensors near the epicenter detect the initial, weaker waves and send alerts before the stronger, damaging waves arrive farther away. This can give people enough time to take cover, stop trains, shut down industrial systems, or isolate power grids. But it's important to be clear. Early warning systems do not predict earthquakes. They react extremely fast once an earthquake has already started. Artificial intelligence has also entered the conversation. Machine learning models are being trained on massive seismic datasets to identify patterns humans might miss. Some systems can detect microquakes and subtle fault movements more accurately than before. However, AI faces the same fundamental limitation. There is no known physical signal that reliably appears before all earthquakes. Without a consistent precursor, even the most advanced AI cannot predict what does not leave a clear signature. Satellites can measure tiny changes in Earth's surface using radar and GPS. These tools help scientists observe slow ground deformation and fault movement over time. They are excellent for understanding stress accumulation, but they still cannot determine the precise moment a fault will rupture. The problem is not a lack of data or computing power. It is the nature of the system itself. Earthquake behavior is chaotic. Small, unmeasurable variations deep underground can determine whether stress is released today or decades from now. This sensitivity makes short-term prediction extraordinarily difficult, if not impossible, with current understanding. There is also a serious ethical dimension. False predictions can cause panic, economic damage, and loss of trust. In the past, earthquake prediction claims have led to unnecessary evacuations and severe consequences when the predicted quake did not occur. Because of this, most scientific institutions are extremely cautious. They prioritize accuracy, transparency, and public safety over bold claims. So where does that leave us? While we cannot predict earthquakes, we can prepare for them. Improved building standards, resilient infrastructure, public education, and rapid response systems save far more lives than prediction ever could with today's tools. The future may bring new breakthroughs. Advances in geophysics, sensor technology, and AI may one day reveal precursors we do not yet understand. But for now, the honest scientific answer remains clear. Earthquakes cannot be reliably predicted with today's technology. What we can do is detect them quickly, forecast risk probabilistically, and design societies that are resilient when they occur. Sometimes the most important progress is not predicting the future, but being ready for it. If you found this explanation useful, like the video, subscribe to Talking Tech, and share it with someone who's curious about how science really works.